Hi all, welcome to this video. In this video I am going to discuss about resistance transducer. Resistance transducer means the transducer which varies its resistance based on a quantity, which is known as resistive transducer. That means the transducer changes its value based on an input quantity. Let's suppose I want to measure the temperature in a room temperature. So based on the variation in this temperature, this transducer changes its resistance value. By changing this resistance value or by measuring this resistance value, we can get the measure of this input quantity. So resistance transducer is a device which varies, is a transducer which varies its resistance in accordance with a quantity, is known as resistive transducer. It's mainly used to measure the physical quantities like pressure, temperature, displacement, force, strain, stress, pressure, etc. This all can be measured with the help of resistive transducer. How it will be measured? It shows the change in resistance. This change in resistance can be used as measurement for the output quantity. Then let's see the working principle of resistive transducer. Here's the formula. Resistance R is equal to, here this is the resistance. Resistance R is equal to rho L upon A, where this L means length of the conductor and then A is the area of cross section and rho is the resistivity of this conductor. So we can see this from this formula. We can say that this resistance is always measured in ohm. This resistance R is directly proportional to the length of the conductor and inversely proportional to the area of cross section. So if change in any one of this quantity, it will affect the resistance also. Okay, then so if you want to change the resistance value, any one of these values can be changed, and by changing this any one of this value, it will affect the resistance also. By changing from this change in resistance, we can measure the output, measure the input quantity. We will get the corresponding output. Okay, then we told that this resistance transducer can be used to measure the physical quantities like temperature, pressure, displacement, etc. Let's suppose I just want to measure the room temperature. What is the working principle of this resistance transducer? This change in temperature may cause the change in resistance of this transducer. This change in resistance can be used. This change in resistance value, resistance change value can be generated as an output. That means we will get the output corresponding to the input quantity temperature. And here we can see how the displacement can be measured by using a resistive transducer. Here there is a slider. This is the resistivity of the material. Here the slider is placed on this resistive element, and this slider can move. We are going to measure the displacement. That means this slider can move horizontally, upward and downward direction. It can move. The slider can move. We are going to find out whenever the slider is moving through this resistive element, how it affects the resistance, and also from this resistance change we can get the output voltage. Okay, here when the slider is moving to this full output slider position, its resistance value changes. Initially the resistive element has a uniform resistance value. Here now the slider is placed in the center of this resistive element, so the resistance between these 2 points, this first terminal and up to this slider is R1, and the resistance from this position to this zero output position, the resistance value is R2. So whenever I am changing this slider, its resistance value also changes. This resistance value also changes. If the slider is moving downward, this resistance value R2 changes. Okay, and this change in resistance can be measured by using a meter. It can be converted into a voltage and that can be measured. That means here the displacement is happening by moving the slider upward and downward direction. It causes the change in resistance, and this change in resistance will affect the output voltage also, and from this output voltage we can identify how much displacement is happening here in this resistive element. Like this, we can measure pressure also, temperature also. Whatever input quantity we are using, this resistive transducer varies its resistance value. By changing this resistance value, by measuring this resistance value, we can understand the input quantity, how much pressure is there, how much temperature is there, how much force is applying on here. These all quantities can be measured by using this resistive transducer. It changes its resistance value based on the input, and from this resistance change we can measure the corresponding output voltage in the circuit, and from this output voltage we can understand how much pressure is there, how much temperature is there, what is the input quantity. Okay, next we are going to discuss about the applications of resistance transducer. The first one is potentiometer, second one strain gauge, third one resistance thermometer or thermistor. This potentiometer is mainly used to measure the displacement. So when the displacement is happening, according to this displacement, this transducer changes its resistance value, and by measuring this resistance change we can identify the amount of displacement. So potentiometer is mainly used to find the displacement. Next is strain gauge. Strain gauge is mainly used to measure a strain applied on a material. That means whenever the strain is applied on this material, this transducer changes its resistance value. By measuring this resistance value, we can identify how much pressure or how much strain we have applied on this material. And the next one is resistance thermometer or thermistor. As the name suggests, it is mainly used to measure the temperature. So when the temperature is changing or varying, according to that the resistance of the material also changes. By measuring this resistance change, we can identify, we can understand how much temperature is there. So let's suppose I would like to measure the room temperature. This thermistor can be used. Okay. Next, what are the advantages of resistance transducer? It is first one, fast response, available in various sizes, low cost, easy to operate, used to measure long displacement, and then high electrical efficiency. These all are the advantages of this resistance transducer. So in this video we have discussed about resistance transducer and its working principle, and also we have seen an example to measure the displacement, and then applications. After the applications, potentiometer to measure the length or displacement. Second one is strain gauge. Strain gauge is mainly used to measure the strain applied on it or pressure applied on it. And then next one is thermistor. Thermistor is mainly used to measure the temperature. And the advantages: fast response, available in various sizes, low cost, easy to operate, used to measure long displacement, and high electrical efficiency. Okay, thank you for watching.